Hi, this is a video about ratio and proportion. Ratios, we see a lot of ratios in our daily lives. We usually compare two numbers. Whenever we are comparing two numbers, more or less we are using ratios. And a lot and very quite often we see we find it really necessary to find out how many times one number is greater than the other, or or in other words, we often need to express by what amount is one number greater or lesser than the other. So in this video we'll be covering various concepts related to ratio, namely, first of all, the concept what is a ratio, then comparing ratios. This is one really amazing, really beautiful exercise. You'll see we can compare ratios in one go using a simple technique, ranking them, of course. Whenever we are comparing ratios, we are ranking them. Then in the next thing could be continuous ratios, variations, partnerships, and so on. So let's begin with understanding what a ratio is. Okay, so what is a ratio? Ratio, for you to find ratio between two numbers or between any amount of numbers, it is necessary that they should be homogeneous, that those quantities should be comparable. When I say comparable, let's see what do I mean when I say comparable things. For example, if my salary is 20,000 and my friend's salary is 10,000, so what I'm doing here is I'm comparing my salaries. So 20 and 10, they're in salaries and they're comparable. So ratio of salaries is 2:1. When I say, let's say I assume I walk 8 kilometers a day and my friend walks 6 kilometers a day. So what exactly I'm doing is I'm comparing the distance which we walk, which is again comparable. Ratios 4:3. But let's say if I say my salary is 20,000 and my friend he walks 6 kilometers a day. What I'm trying to compare is salary with walk. No, that's not comparable. So I not compare it. Okay, so next, moving on to comparing ratios. How can we compare ratios? How can we rank them? We'll see. We'll use a very straightforward, simple technique. We'll not go back to those using LCMs or using decimals. It's a simple technique. For example, let's say we want to rank. I'm writing down a few ratios. Let's say 2:3 is a ratio, 5:6, 13:14, 7:8. Let's say I want to rank them. Which one is the highest? And then moving on to the lowest one. Okay, I want to write them in descending order, which means the highest first. I'm writing down these numbers again. So what I'll be doing is I'll see the difference between the numerators and the denominators of each fraction of each ratio. I'll see the difference between the numerator and the denominator. In the first case, the difference is 1. In the second case, again, the difference is 1. In the third case, difference is 1. And in the last case, difference is 1 again. So what I've seen here is that difference is 1, which it is same in all the cases. Whenever the difference is same, what you need to do is you just need to see the numerators. Just compare the numerators. The greater the numerator, the greater will be the fraction. In our case, 13 is the highest number, so 13 by 14 will be the largest fraction, followed by 7, then 5, then 2. So now we have ranked them as well. 13 by 14 is rank 1, 7/8 rank 2, 5/6 rank 3, and 2/3 as rank 4. What we did was we saw the numerators and then we saw the denominators and we found their differences and we saw that the differences were same. So we went on to see the numerators, and the greater the numerator, the greater will be the fraction. It was an easy one, very easy one. The differences were same and you won't really encounter many examples using same differences. Let's move on to slightly better example. Let's say we want to compare, we want to rank these numbers, and as you can see the difference is not same now, difference is varying. Here the difference is 1, then it's 2, then it's 2 again, then it's 1. Difference is not same. So in this case, when difference is not same, again, like this, the technique is really simple. What you need to do is divide the numerator, which is, for example, in first case it is 5. Divide the numerator with the difference 5 by 1. Then similarly 17 by 2, 11 by 2, and 15 by 1. So what we'll get is dividing 5 by 1, dividing the numerator by the difference, we'll get 5, 17 by 2 we'll get 8.5, 11 by 2 we'll get 5.5, and 15 by 1 we'll get 15. So the ranking is pretty straightforward. 15 gets rank 1, 8.5 rank 2, 15, 5.5 gets rank 3, and 5 gets rank 4. So we've ranked the ratios again. Another example, slightly more better, is let's say there are 5 numbers, 5 fractions, and these are the 5 fractions. You have to rank them. In the first case, difference is 1, then it's 2, then it's 2 again, then it's 3, then it's 5. Differences, they are varying, but we need not fret. We know the technique. We'll divide the numerator by the difference. 7 by 1 is 7, 15 by 2 is 7.5, 17 by 2 is 8.5, 23 by 3 is 7.66, and 31 by 5 is 6.2. The ranking is pretty straightforward now. Highest number will get the rank 1, followed by second, then third, then fourth, and 6.2 as the last. Alright. Moving on to the next concept of continuous ratios. Continuous ratios, we'll move on to the concept, but first of all we need to understand a few basic things. For example, let's begin with an example. For example, let's say there was this farmer who had a wealth of, let's say, 12,000. He had cash with him, 12,000, and he wanted to give it to his two sons, A and B. Pretty cliched, I believe, A and B. But alright, for the sake of example, let's move on with the names A and B only. A and B will get the wealth in the ratio 1:2. So how do they actually get it? Add 1 and 2, you'll get 3. 1 plus 2, you got 3. So A's and B's share would be, A will get 1 by 3 of total and B will get 2 by 3 of total. What you did was you added these two numbers to get this number. 1 plus 2 is 3. So A's share would be 1 by 3 and B's share would be 2 by 3. And so A's 1 by 3 of total is 1 by 3 of 12,000 is 4,000. 2 by 3 of 12,000 is 8,000. That's it. So we found the shares. Okay, moving on to another example. Let's say a farmer had a wealth of 60,000. A and B to be divided into ratios 9 by 11. Add them up. 9 plus 11 is 20. So A's share would be 9 by 20 and B's would be 11 by 20 of the total. So 9 by 20 is 27,000. 11 by 20 is 0 cancel 33,000. Alright. Let's say the farmer had 3 children, A, B, C, to be given wealth of 50,000 in the ratio 10:8:7. Add them up. 10 plus 8 is 18, plus 7 is 25. So A's share is 10 by 25, B's is 8 by 25, and C's is 7 by 25 of the total. That's it, pretty much it. So let's assume a case where we are not given the ratios straight away. A's to B's to C is not given. Rather, it is given in a form like this. A by B is this, is let's say 1 by 2. B by C is, let's say, 2 by 3. We're not given a continuous ratio. A's to B's to C, we're not given that. But it's pretty easy to find out. What we need to focus on is that number which gets is that figure which gets continued. In our case, it is b. B gets continued. B is the thing which is continuing. It was in the it was in this fraction, it is in this fraction as well. So we'll focus on b, and we'll have to make it equal in both the fractions. Since this is an easier one, this is an easy example. B is same here. It is 2 here as well, and it is 2 here as well. So we can easily find the continuous ratio a is to b is to c as we saw that b and b are same, so continuous ratio would be 1 is to 2 is to 3, and we can find the share as well. 1 plus 2 plus 3 is 6, 1 by 6, 2 by 6, and 3 by 6. That's it, pretty much it. Okay, a better example. Let's say a by b is 1 by 2, b by c is 3 by 4. This time b and b, they are not same, so we'll have to make it same. One easy way of making both the b's same is multiply this b by 3, and in the next step we can multiply this b by 2. So both the b's are same now, they are 6 now. But since this ratio got affected when we multiplied b by 3, so we can multiply a by 3 as well, so that the ratio stays the same, and the lower c by 2, so that this ratio stays the same as well. So a by b becomes 3 by 6, and b by c becomes 6 by 8. So the continuous ratio is 3 is to 6 is to 8, and we can sum it up and we can find the respective fractions as well. 3 by 17, 6 by 17, and 8 by 17. Okay, another advanced question could be a by b is 3 by 5, b by c is 2 by 3. Similar technique. B, we'll try to make b same, 5 into 2 and 2 into 5, and keeping the fractions in balance, multiplying a and multiplying c accordingly, we get a by b as 6 by 10, b by c as 10 by 15, a is to b is to c is 6 is to 10 is to 15. All right. Okay, what if there were three fractions involving 4 numbers? A by b is 1 by 2, b by c is 3 by 4, and let's assume there's another quantity d as well. C by d is, let's say, 5 by 6. We need to find a is to b is to c is to d. There are two continuing numbers, b here and b here, and then is c here and c here. We need to make them same. We need to make them equal. Using the previous technique, first of all, what we'll do is we'll try to balance these two equations. Then we'll try to balance these two equations. And while we'll be balancing these two equations will run out of balance. And then we'll go back and balance these two equations again. Let's see how we can do this. We balanced the first two equations. A by b is 1 by 2. B by c is 3 by 4. We balanced. A by b became 3 by 6. And b by c became 6 by 8. That we've seen how we did it. Now we'll move on to the next two equations. B by c is 6 by 8 now, and c by d is 5 by 6. Balancing them, b by c will change to multiplying by 5, multiplying that by 8. B by c will become 30 by 40, and c by d will become 40 by 48. But in this process, what we have done is we've managed to make these c's equal, but this b and this b, now they have run out of sync. We need to balance them again. So multiplying the previous b by, if we multiply the previous this b by 5, we'll get the equations back in sync again. So a by b is 15 by 30, and b by c is 30 by 40, c by d is 40 by 48. Both the b's are balanced, and now both the c's are balanced as well. So the equation we get, a by b is a is to b is to c is to d is 50 is to 30 is to 40 is to 48. We can do another example, similar example, where you can see where you'll find how we can balance these things, and I'll recap it again. As we'll balance the first two, then the next two, and while we'll be balancing these two equations will run out of balance. So we need to go back again and balance them again to arrive at the right equation. Okay, I'm giving you another example to solve it for yourself. A by b is this, b by c is this, c by d is that. Okay, try to balance it. I'll show you the answer, or you can pause it here and move on to the answer later. So the answer is a by b is, we balance a by b, we balance b by c, we'll balance c by d then, and c by, well, we'll balance c by d. The a by b ratio does not go out of sync, so a by b is to c is to d. Answer, you can check your answer here is 5 is to 10 is to 6 is to 9. 5 is to 10 is to 6 is to 9.